Hey everyone, welcome back to Remote Sensing Pro. If you're new here, this channel is all about making remote sensing and GIS easy and hands-on with practical Python tutorials and real-world examples. Today I will show you how to crop your satellite image or any raster to your study area. We will start by turning the area we zoomed in on in the last tutorial when plotting the NDVI into a shapefile we can use for further analysis or in any GIS tool. Then I will show you how to use that shapefile to crop or clip your satellite image or NDVI raster. If you already have a shapefile from QGIS, ArcGIS, or ENVI, you can use it right away. So just skip ahead to the cropping step. Now let's set the zoom window and find the raster file. I'm going to grab the details we have here when we zoomed in our last tutorial. And use it here. Okay, so these are the pixel rows and columns that we used to zoom in when we plotted the NDVI in the last tutorial. Here we have the row start, row end, the column start and column end. These are the starting and ending rows and columns that we use, for the first one being for the top and bottom, and the second being the left and right. So we have the top, the bottom, we have the left and the right. Okay. Next we're going to use Glob to automatically find one of our raster files. So we can use the file as a reference to ensure that the shapefile that we want to generate is dereferenced and the shapefile matches all other data we have in the folder. So I will import Glob and create a folder. Usually you want to get the path for the folder where you want to extract this file from, or rather where you want to grab the file from. So we'll just grab my file path. So this is the path we've been using throughout the tutorials, and this extracted image folder is where we extracted the images we downloaded from USGS Earth Explorer. Next, I'm going to create band files and use glob.glob and get into this folder. When I get into this folder, I'm going to look for any file that has a certain extension. So I would do b2.tiff. So get into this folder Python and find all the files with underscore b2.tiff. All right. Then take the first result. All right. So you don't have to hard code the file name. Glob does the search for you and grabs the data you're looking for, or grabs the file you want to use. Let me go through this real quick. Glob. Okay, let's run this. Awesome. Next, we want to convert the pixels to real-world map coordinates and build the shapefile. To do this, we'll import Raster And with raster.open, we grab these band files and open it as source and transform. So when you transform source.transform, what this does for us is it lets us convert between the pixel and map coordinates. To convert the pixels of the window to map coordinates x and y, we need the x-min and y-max and x-max and y-min. These grab the upper left coordinates and the lower right coordinates. So we do x-min, y-max, go to raster.transform, .xy, transform. We want to transform the row start and the column start. And so we offset equal to the upper left. Awesome. We are going to do the same for the x-max and y-min. We also transform this using the row end, and column end. And our offset is going to be lower right. Okay, let's have a look at this real quick. So the first one, we have the upper left, and then the second is the lower right. We can print this real quick. We can print F. Let's call this maybe bounding box coordinates. Our x-min is equal to x-min, and x-max is equal to x-max. Y-min is equal to y-min. And the final one is a y-max is equal to y-max. Alright, let's have a look at this real quick. And then the final bracket. And then the final quotes. Alright. Bounding box coordinates. We have x-min. We're going to print this x-min. The x-max is going to be for this x-max. Y-min. We get the y-min here. And the y-max, we grab this y-max. Okay, I think that should work properly. Let's have a look. Awesome. Our x-min is around 45 and the y-min is around 54. While the max, we have 51 for x-axis, and for y-axis we have around 55. Okay, now that we have the coordinates of the bounding box, we can go ahead to build a geodata frame so we can save as shapefile. Also, before we save, we need to set the CRS to match the raster. we need two libraries to get this done. The first is to import bugs and also import GeoPandas. So I'll start with import GeoPandas as GPD, and the second is from Shapefile.geometry. Import bugs. With this now we can get our bugs as bbugs as bugs. Here we have the x mean, the y mean, then x max, y max. So we have the four corners ready: x mean, y mean, x max, y max. Great. So let's grab the geodata frame. We have geodata frame is equal to geopanda.geodata frame. And we have to grab the geometry as the box right here that we just created. And close the bracket. Next is to set CRS to match raster. We do CRS is equal to the raster CRS, which is source.crs. Okay, that looks good. Geodata frame equal to geopandas.geodata frame. We have the geometry. We have the bbox we created right here. And finally, we have the coordinate reference system, CRS, to be equal to our source CRS right here, which is the raster source. And that's it. So next we want to output the shapefile. We could give it a name that sounds good as shapefile. Output shapefile as just out shapefile. Yeah, out is just output, right? And to do that, I will just grab I'll grab this directory, this file path, and I would like to save it as, let's say, zoom window. Yeah, let's keep it constant because that's the window we zoomed in our last tutorial. .shape. Good. So we have the extension .shape for the shape files, and that should work pretty well for now. Alright, so next is to use geodata frame to file and grab this out shapefile. And that's it. To see whether we've successfully saved the shapefile, we could just print it out. We just say print. Let's print it as shapefile saved to where we're going to save it to this time around. Let's see. Let me keep it constant. Alright, saved to here. And we're good. So we have print our shapefile saved to this shapefile, this out shapefile right here. That should work pretty well. Okay, so we have the shapefile saved to our folder, and it's saved as zoom window.shape. So we can actually open this shapefile in any ArcGIS, GIS or remote sensing platform like ENVI, ArcGIS, or QGIS to view it as a polygon, like a rectangle polygon that we just generated right from here. Okay, the next step is to crop a raster with Shapefile. Now that we've got a Shapefile, we can go ahead to use the Shapefile to crop the raster file. Alright, so we don't just keep zooming in anytime we want to view our study area. So when we crop it, we have our study area as the only file we want to process instead of processing the entire image we downloaded from the website. To do that, first we need to import our favorite library, the Raster. Import Raster, and from Raster, we want to import mask. From raster.mask, import mask. And the next thing we want to import is GeoPandas. Since we already have GeoPandas here, we don't need to import GeoPandas again. But let's say you have your shapefile that you don't have to do this step that we've done before. You just want to start from step 3, which is cropping a raster with shapefile. Then you need to import GeoPandas again. This library right here, you need to import it. Alright, so if you already have a shapefile you created in QGIS, ArcGIS, or somewhere else like ENVI, you can use it directly. Alright, just point to its file path and use it in this step. Alright, you don't need to go through the initial step that we did. Okay, so let's create the path to our shapefile. For us, is the shapefile that we just saved, and for you, it could be the shapefile you already have before this video. Just create the path and import the directory or the file path for your shapefile. Shapefile is equal to, I'll grab mine. Next file I need to import is the raster file. Let's get the raster. I will call it raster to crop. That sounds cute. I'm gonna grab the file path to my raster. I'll just come here to grab this file path. I will just do band 4 to use band 4, and I'll run this again. I will just print this so I can get the file path from here. This actually is an easy way to get this done, and I'll use it here. Okay. Well, I don't like double. I need to remove this right away. So I have my file path, which is the band 4 that I want to use, the band4.tif, and I have the R because of the backslashes that we have here. Now let's read the study area as our shapefile. Study area is equal to geopanda.read file. We're going to read this file as shapefile. The raster to crop and want to read it, right? Usually we do with rasterio.open. Open as source. Now let's reproject the study area to be the same CRS as the raster. We do that by get the study area dot to CRS with the source dot CRS. Here we want to reproject the study area right here to the raster's CRS. And so we just define the new study area we want to maintain the name as study area, and we want to reproject it to CRS. Which CRS? The source.crs. Let's extract the geometry. We'll say geoms study area the geometry. Okay. The values. Alright. So we do geoms equal to study area dot geometry dot values. Next, we want to now mask, or we want to crop the raster with the polygon. Okay, to do that, we're going to get the output image, the output transform, and then we're going to mask it using the CRIs, the geoms, and also set the crop as true because we want to crop it, right? So we're going to do output, or I'll just do out to make it short. Out image and out transform equal to mask. We're going to mask CRS geoms, and we'll set the crop to be true. Let's output the meta with the new size and transform. To do that, we just create the output metadata information and use it to save the new file. So let's do output. Let's just do out. Do we need the entire output? Let's do output, then output meta.update. So we need a couple of info here. The first is going to be the GeoTIFF driver, and we create the shape, and then we create the transform. Let's get the driver. Next we have the shape, so we do the height and the width. And finally, we transform. Right, let's fill in this. For the driver, we're looking at the GTIFF. Okay, we need this as a string. GeoTIFF. And the rest, we have our out image. So I want to grab the shape of this image. The first one being the height. We do the same for the width. To grab the second one for the width. And finally, we want to get the output transform. We should have it somewhere here. Okay, we have it as out transform. It's very important to keep them constant to avoid error. We have transform as out transform, width, out image dot shape 2, height, out image dot shape 1, driver, GTIFF. Okay, that should work. So now we can get those commas and close the bracket. Alright, let's run this code. Yeah, it went well. The next thing is to save the cropped raster to a new file. We've already done everything. The next is just to do the saving. We're going to write it using the metadata. We'll give it a name, cropped. Yeah, it's going to be cropped output is equal to, I'm going to grab the file path. I'm going to name it something very easy to remember. Once I look at the image, I know this is the cropped image that I just did, and I will save it as geotiff.tiff. Okay, and I will do with Raster that open this output right here, and you're going to write it this time around, and write using this, what is output meta. Okay, we have the output meta, and we'll do that as, do we do O? Let's say F. F dot write. Alright, okay, R is missing right here. To upload this image, we'll call it out image. Alright, we're almost there, and finally we just want to print it out. We'll do print cropped image saved as, want to save it as this right here, the cropped output. Alright, let's go through this. We have the cropped output, and we have the file path. We named the image as cropped image.tiff. With raster.open, we want to save this cropped output to this file. We want to write it, and what this does is that it unpacks the metadata dictionary, which tells Raster how to set up the new file based on this, right? Based on the driver, the shape, the transform, CRS, and others. We write the out image. Okay, and now I want to print the cropped image saved as. Something is missing. As cropped output. Alright, so this should work for now, but let's give it a try. Awesome. We've got the cropped image saved as cropped image.tiff in this folder. Alright, so I'm going to either use a GIS platform to visualize this, or just use Python to visualize it. And for the purpose of this video, we would like to visualize the cropped raster we just saved. Okay, let's do that. Import matplotlib.pyplot as plt. And because we just saved this file, we want to read the file so we can visualize it. So we'll do with raster that open, want to get this cropped output, and read it as source. Can read it as anything actually, as F or anything. I want to read as source, and we'll give it a new name as image source.read 1. Okay, just read the first band. Next is to now use our usual plot.figure. We have fig size equal to, let's do 2 is too small, let's do 4x4. And we'll do plt.imshow. Let's have a look at the image. And we'll do CMAP, right? CMAP, what are we setting today? Let's do gray. For sure it's gonna be gray because we just read one band. And we'll do plt.show. Okay, let me have a look. Import matplotlib.pyplot as plt with raster.open. Open the cropped image, this image right here, as source. Then we named it image img equal to source.read the first band. And so we set the fig size as 4x4. Then plt.imshow, we want to read this image. We set the CMAP as gray and I want to show it. Let's have a look. Awesome. So here we have the image that we zoomed in the last tutorial. But the difference here is that this image is a raster file right now and not just an image that we viewed. So we have a file for this image as a raster, and we also have a file for this image as a shapefile. So we have the bounding box that we first did, and with that bounding box, we're able to crop the real raster to get this specific location. Now we can open this image in any GIS platform or remote sensing platform, and we're going to just see this exact location. We're not going to see the bigger size anymore because we've just cropped our raster. All right, so I'm going to open a GIS platform or a remote sensing platform right now so we can see how it looks like as compared to the bigger or the larger area that we downloaded. So let me grab that right now. Here is the download we have that we're working with all this while, the raster file, and this is the cropped image. So once you remove this bigger one, you are left with your study area that we just cropped using the bounding box. This you can always do using any shapefile that you want to use for your project or any report you're working on. All you need is a shapefile in form of a polygon, and you import the shapefile. You get to your raster, which is the bigger part of the image, and crop it to your study area based on your shapefile. All right. So thanks for watching today. Now you know how to turn any zoomed in area or any custom region into a shapefile and how to use that shapefile to crop your satellite images or any raster map in Python. This workflow works with any shapefile, including ones you create in QGIS or ArcGIS or even ENVI like this one, so you can easily focus your analysis on just the area you care about. If you found this helpful, please give it a like, leave your questions or feedback in the comments, and subscribe for more remote sensing and GIS tutorials. See you in the next one.